Hello, geometry class, and welcome to this video on section 11.7, ratios of areas. So in this section, you'll be asked some questions that just says, here are these two figures, find the ratio of the areas. And obviously, one of the ways of doing that is if there's enough information, actually find the area of both shapes and just write them as a ratio. Make sure you always reduce ratios to lowest terms. And so we'll see that in this example here. So in the diagram, AB is 5, BC is 2. What's the ratio of the two triangles, ABD and CBD? Now, we actually don't have enough information to find the areas of both triangles because we're missing the height, but we're told that AB is 5 and BC is 2. So the area of triangle ABD would be, so say ABD is going to be equal to 1/2 times 5 times that height. And the area of triangle CBD is, let's write it like that, CBD is equal to 1/2 times 2 times the height. Now, since we don't know what the height is, we actually can't find what the actual numbers are and then write them as a ratio. But if I were to look at these two things and put them in a ratio, notice that the 1/2s cancel. The h's also cancel. It's the same height. Okay. And that's, I didn't use a different variable because the height of the green triangle and the height of the blue triangle are the exact same height. So that's why they're both h, and that's why they can cancel. And I'm left with a ratio of just 5:2. Okay. Something you might have known. Theorem 109 in our book says if two figures are similar, then the ratio of their areas equals the square of the ratio of corresponding segments, or what we call the similarity ratio. That's what this is here, S1 to S2. This is the similarity ratio. So if we know the similarity ratio, the ratio of the areas is just that ratio squared. So A1 and A2 are the areas, S1 and S2 are measures of corresponding segments. Now, they're very careful to say segments and not sides because you could be looking at circles, which don't have sides, but they also could look at things like the lengths of altitudes or medians drawn from corresponding vertices, or corresponding chords in circles or something like that. So they're just corresponding segments. S1 and S2 are the ratios, are the measures of corresponding segments. Okay, so let's take a look at two examples here. The first one says, given the similar pentagons shown, find the ratio of their areas. Now, I have no idea how big either of the pentagons are, other than to say that one has to be bigger than two because the corresponding sides are given 12 and 9. So the ratio of the sides are 12 to 9, which is 4:3. And if I want to get to the ratio of the areas, I'm going to take this and square it and get 16 to 9. So that is the ratio of the corresponding areas. Okay, the second one says, if the ratio of the areas of two similar parallelograms are 49 to 121, find the ratio of their bases. Now, I mean, I'm sure you're looking at that and just saying, okay, it's obviously 7 to 11. Yeah, you're just going to take a square root of 49 and 121, and that's going to be the ratio of corresponding bases. So that would be 7, and that would be 11. So maybe the better question is, what's the ratio of their perimeters? Now, how can we figure that out if all we have is a length and we don't have a width? So we'll call that width 1, and that's width 2. That's a good question. Okay, well, keep in mind that the figures are similar and the widths are also corresponding segments. So the ratio of width 1 to width 2 is also going to be 7 to 11. So I don't really know what width 1 and width 2 are as far as numbers go, but let's call them 7x and 11x, where x is whatever that common ratio is, whatever the I'd have to multiply by to get, but by 7 to get W1 and by 11 by to get W2. Okay. So the perimeter of 1 is going to be the 7 and the 7. I guess I can't really even assume that that's 7. I guess we should call that 7y. We should call this 11y. So the ratio of parallelogram 1 is going to be 7x plus 7y plus 7x plus 7y, the two lengths and the two widths, or 14x plus 14y. And the perimeter of parallelogram 2 is going to be, see, I have two 11x's are my widths, two 11y's are my lengths. So I'm going to get 22x plus 22y. We can see that this ratio on the top, I can factor out a 14, be left with x plus y, and the bottom 22 and be left with x plus y. So whatever x and y are, whatever those common ratios are, I can cancel them, and I'm left with 14 over 22, which also reduces to 7 over 11. So the similarity ratio is the same as the ratio of the perimeters. Okay, so that's what I got for you here. We'll do some more examples tomorrow. These things can get a little complicated. I would say what you should look for as we go back to the first problem is if you have two shapes that make up a bigger shape, look for common sides, or if they share the same height or something like that, and that might be what'll help you out.